Hi everyone, this video today is going to cover lesson 1.5, which is on segment constructions. And even though it's called segment constructions, this lesson this year is going to be a little bit different because we are not together in person, and so we're not actually going to be doing any constructions. So even though it's called segment constructions, we're not actually constructing. We might come up with a different name for this unit or this lesson. But anyway, we want to talk about segments. Last time we talked about lines. The difference between a line and a segment is that a segment is finite. It has an end to it. And we show that end with those big dots on the end. Those dots show us that that segment has an end. And so the name of this segment is segment DL. And when we draw it, we put a little bar over it like that. There are no arrows on it. It's just a straight line like that, like a bar. Also, we could call it DL or we could call it LD because once again, the segment goes both ways. And so once again, we can do some practice here with this one. This segment, there's actually a couple different segments. One is segment AN, or we could call it NA, and those need bars up above them. That's one segment. Another segment is segment NH, or we could call it HN. And there's a third segment, and that is the segment AH, or HA. And each of those is a different segment. You can tell there's a different length to them, and so each segment has a different length. They're actually separate individual segments. If this has was a line, if it had arrows on the end, then these would all be the same thing. But segments are finite and they have a specific length to them. And so we can't kind of jumble all those together this time. We have to separate them out into three separate things. And so that leads us into the segment addition postulate. And so here you can read the postulate. If a point is between two other points on the same line, it's collinear, then the sum of the lengths of the two smaller segments is equal to the larger segment. And I think this is going to be pretty obvious if I point something out to you. Let's go back to this one before. Let's say this segment had a length of 1, like 1 centimeter. And let's say this one had a length of 2, like 2 centimeters. Well, then how long would AH be? Well, wouldn't that be 3? Okay, doesn't that make sense? So what this postulate is saying is if you have two segments that are collinear in a straight line, this is a 1, this is a 2, you could add them together and say the whole thing is 3. Okay, pretty obvious, I think, when we say it that way. So if B is between A and C, then AB plus BC is equal to AC. And I'm going to put my segments up above there. I really think I should say congruent to. But the idea is those two pieces added together would add up to the whole thing. Okay, so if we look at this, it says use the segment addition postulate to find XZ. This is kind of what I was just talking about a second ago. If we need to find XZ, well, aren't we just going to take 23 plus 50? Now in geometry, we might go through and say it a little more specifically. We might say that XY plus YZ is equal to XZ. And XY, we could sub in a 23 for XY. We could sub in a 50 for YZ. And so that would equal XZ. And so if we add those two together, we would get 73 is equal to XZ. That's kind of like the more formal way to do it. But I think we can all see it makes sense. That's what it is. All right, and that all depends on these being in a straight line. So the next question says, in the diagram, WY is equal to 30. So I'm going to write a 30 there because it said WY. Here's WY, and that's 30. Can you use the segment addition postulate to find the distance between points W and Z? Okay, could we say that this is 53? No, we can't say that's 53. The segment addition postulate does not apply here. Why not? Well, because they're not collinear. They would have to be collinear in order for us to do that. Okay, those were pretty obvious. Well, maybe not. But now this is a little bit harder. Not a whole lot harder, but a little bit harder. I'm going to go ahead and do it like the long formal way. And then we can maybe talk about how you would just see that logically, because some of you probably can see it logically. So my long formal way would say that VW plus WX is equal to VX, right? Because here's the first segment, here's the second segment, they add up to be the third segment. And now I can do some substitution. I could say, okay, well, VW is actually 37. Now I don't know WX, that's what I'm looking for. But I can also say that VX is 144. So now I can just solve this equation by subtracting, I need a plus here, by subtracting that 37 from both sides. And when I do that, I get 107. So again, this is kind of like the long formal way. Some of you might have just seen, well, you're just going to subtract 144 minus 37. That's going to get you there. That's true. And that is 107. Okay, in this last part, you know, and all above here and throughout these notes, we do these like boxes with information. And down here, I think we kind of forgot that box. I think we might need that box. On my paper, they've been green, so I'll color it green. But now it looks like one of those boxes up there. So you might just make a little text box kind of thing, because we're talking about congruence here. Well, what does congruent even mean? We've never heard that word before. So congruence is things that are the same size. And there's a symbol for congruence, and I used it just a second ago. I've kind of run out of space here, but this symbol for congruence is an equal sign, but it has a wavy line on top of it. I'm going to write it down here a little bit better. Okay, that's the symbol for congruence, an equal sign with a wavy line. What it means is they're the same size. That's what congruence means. So it says mark the following congruent parts on this figure. So it says ZU is congruent to WV. All right, where's ZU? Here's ZU. I'm going to put a little hash mark on it. And WV, I'm going to put a hash mark on that. What that means is, again, let's just say this is centimeters. Let's say this is 5 centimeters, and this is marked. This is also 5 centimeters. Okay, once we've used the 1 tick mark, we now need to go to 2 tick marks and then 3 tick marks. So the next one is YU, which is right here, is congruent to XU, which is right here. And so once again, like if this is 2 centimeters, this is also 2 centimeters. YW is here. I'm going to use 3 tick marks, and XW is here. So once again, if this is like 10 centimeters, this is also 10 centimeters. Okay, and so I went ahead and wrote that in there. Congruent parts are marked with the same number of hash marks. And so that's what those little tick marks mean, is that they're congruent. Okay, let's turn the page. I have some good news on the next page, and that is that we can skip it. Woohoo, we're skipping the page.